In this video, we're going to look at the program entry point for a Solana program. Now, the entry point of a Solana program is where the execution of the program begins, and we generally define it using this entry point macro. A Rust macro is effectively just a function that takes code as input and produces code as output. In this case, we're passing in some function that we define that requires the following parameters. If we take a look at the implementation of the entry point macro, we will see the following code. So the entry point macro takes in some function as input. It produces the following code. In this case, it's a function called entry point that takes in some bytes as input and produces a U64 value. Within the body of the function, the inputs are passed to a function called deserialize, which generates three values called the program ID, count, and instruction data. And these three values are then passed into the function that we pass into the entry point macro. And then based on whether this function executes successfully given these values, the entry point function either returns OK or an error. And that's the basics of a Solana program. If we were to expand this macro, we would see the following code. So here to the left, we have our entry point, which expands into this code here, where we can see we have our entry point function that takes in some bytes that passes these bytes to the deserialize function, producing these three values. These three values are then passed to our process instruction function that we gave to the entry point macro. These three values here correspond to the parameters of the process instruction function here. And based on whether the body of our process instruction function returns successfully or not, is going to determine whether the entry point returns OK or with a success value or an error. Next, let's take a look at a Solana program built using the Pinocchio library. This is a replacement for Solana program with performance optimizations. Moving forward, you should build your programs using Pinocchio instead of Solana program. So just as before, our program has an entry point that's defined using an entry point macro, except this macro comes from Pinocchio. If we were to take a look at the entry point, we would see that this entry point is slightly different, where we call the entry point, it recursively calls itself, and then calls this program entry point macro. Here in the body of the program entry point macro, we can see that it defines our entry point, where we still take in some bytes and produce a U64 value. Taking those bytes, it still passes it to a deserialize function that produces a program ID, some count, and some instruction data. So we're getting a count instead of account infos, and then these values are passed to our program that we passed into our program entry point, just as before. And based on whether our function processes successfully, the program either returns OK or an error. If we were to expand this macro, we would see the following code to the right. Just as before, we have our entry point that takes in some function that we define that requires three parameters. And then what this entry point macro expands into is the following code here. And what we're going to focus on is this first function here, where we have our entry point that takes in some bytes and takes those inputs, deserializes the inputs into the following three values, passes these three values into the function that we gave to the entry point macro. And then based on whether our function returns successfully or not, the entry point will return either success or an error. The main thing to note is that even though the implementation of the entry point is different, it still has the same function signature, where we just take in some bytes and return some U64 value based on whether some function that we pass into the entry point returns successfully or not. Next, let's take a look at an Anchor program, where Anchor is a framework for writing Solana programs that leverages Rust macros to reduce the amount of boilerplate code we have to write. Now, if we were to expand this program macro, we would see that the program macro still generates an entry point function for us that takes in some bytes as input and produces a U64 value. The inputs are still passed to a deserialized function that produces three values that are passed in to an entry function that is generated for us. And based on whether this entry function returns successfully or not, the entry point function returns OK or an error. Here we can see the entry function that was generated with this program macro, where the entry function requires the following three parameters that we expect in the function that we pass into the entry point function. The body of the function will call a try-entry function that passes in the parameters to the function, where we can see for the try-entry function, it will call a dispatch function, passing in the three values. Next, we can see that the dispatch function that was generated for us requires the same three arguments. It then takes the instruction data, gets the first 8 bytes from it, and then uses those 8 bytes as the instruction discriminator. So with an anchor program, the first 8 bytes of instruction data is used to identify the specific instruction to invoke on a program. So it's actually matching against the first 8 bytes. And if it matches the one for a specific instruction, that is how the instruction is invoked. So if the first 8 bytes matches what's expected for the initialize instruction, then we call the initialize instruction, passing in the program ID, accounts, and instruction data. The main thing to note is that even with an anchor program, we still have the same entry point that takes in some bytes as input and produces a U64 value, where the input bytes are deserialized into the same three values and passed to some function. And based on whether that function returns successfully or not, the entry point will either return OK or return an error.